And section 1 of chapter 1 starts off with this idea of algebraic expressions. And what that means for us is basically the introduction of variables or letters like x, y, z, for example, that take on various values in an expression. And what we're going to focus on today is basically how we read algebraic expressions and how we create algebraic expressions from words. So here are some examples of algebraic expressions. We will call this, in terms of how we read this is the sum of x and 4, if you were to say that in the written language or in English. This one here, 5x, notice if there's no operation between the two terms, if you will, the 5 and the x. We would say that this is to be multiplication. So the way we describe multiplication is the product. So this is the product of 5 and x. Here's another product problem, but also we now have the power of 2, so that's the exponent 2 with the base x. So this is the product of 5 and x squared. This idea of squared, we can also say it's the product of 5 and x to the second power. We use the word squared because that refers to something to the second, but as you get to higher powers, there's no one word that describes it, so we can just describe the power it's raised to. So if we have something, for example, like this, 5x plus 3, we sometimes refer to this as the variable term. That's the variable term because it's the term that has the variable. There's two terms in this. There's the 5x part and then the 3 part. And the term that doesn't have any variables, we call this the constant term. Constant term. The word constant means never changing, so this is always going to be 3. So that's why we use the word constant. This is variable because depending upon what x is, it varies. It could be, if x is 2, this would be 10. If it's 3, it's 15. So it varies. Hence, it's the variable term. Constant term, variable term. Okay. In your textbook, there's a little section there that shows this chart, a very important chart for us to look at today, that shows us the various words and how we explain those words in math. So let's take a look at some of these operations. So if you have the operator or you're describing addition, the key words that you would see in terms of this, you see something like the phrase more than, the sum of, plus, increased by, added to. So all these phrases here imply that you're going to be using addition. If you're going to be subtracting values, you would see phrases such as less than, subtracted from, difference, decreased by, or minus. Multiplication. In algebra, we use that little dot there sometimes to refer to multiplication. The product of, multiplied by, times, or of is sometimes used to describe multiplication. And then division, quotient of, divided by. So take a moment to put this chart into your notes somewhere because you're going to refer to it in terms of how you build algebraic equations, or expressions rather. So here are some examples that are right below that chart in your textbook. It asks us to write an algebraic expression for the verbal expression. Usually that's what we do. Is think of it as like a word problem. You're going to have to decipher the words into mathematical language. So if we see something like a number t more than 6, t more than 6. So here's 6, t more than it means plus. So we're going to add. And then there's the variable t. Because there is a commutative idea in addition, you could put t plus 6, but the way it's written, it's t more than 6. So here's 6 and more than it t. So that's the way we write it in that form there. 10 less than the product of 7 and f. So the product of 7 and f means multiplication. So 7f And then 10 less means minus 10, so that's how we get that expression. 2/3 of, so the word of again implies multiplication, so it's 2/3 as a fraction of the volume V, so 2/3 of V. Another way to write this, because V is a fraction, remember every whole number is a fraction over 1, so this is 2/3 times V over 1, which allows us to write it as 2V over 3 when you multiply straight across, so that's how you get those expressions. So especially in fraction work, you'll sometimes see the variable kicked in the numerator of the fraction up top instead of next to it, and that's the reason why we're allowed to do that, is because you're multiplying two fractions really. Alright, so some guided practice. So take a moment to figure out what this is going to be in terms of an algebraic expression. Go ahead and hit pause and then work them out, and then I'll show you the solutions in a moment. Alright, so the product of p and 6, so that means 6 times p because it asks for product, it means multiplication. You could write p6, but it's always best to put the variable after the number. 1/3 of the area A, so 1/3 of the area, so of means multiply, so 1/3 A also can be written as 1/3 times A over 1, which gives us A over 3 as a more simplified version of that answer, A over 3. Alright, so that's the basic gist of getting these things together, either writing them in words or taking the words and writing them into algebraic expressions. Go ahead and practice that in your assignment today, and we'll see you next time.